Welcome to the Real Python Podcast. This is episode 204. Would you like to get more practice working with APIs in Python? How about exploring the globe using the data from OpenStreetMap? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We share an article from the Pybites blog about building queries using the Overpass API for OpenStreetMap. The post explores the data structures, tags, query formats, and how to use Overpass in Python. Christopher discusses a Real Python article by recent guest Stephen Gruppetta about lazy evaluation in Python. The piece covers the advantages of generator expressions or functions, and the potential disadvantages of using lazy versus eager evaluation methods. We also share several other articles and projects from the Python community, including a news roundup, handling Control-C and Asyncio, preventing data leakage in pandas and scikit-learn, discussing the Django developer survey results, asking developers why they aren't shipping faster, using UV to install into isolated environments, and a couple of tools for retrying in Python. This episode is brought to you by Sentry. Fix application issues before they become downtime with Sentry error and performance monitoring for Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So we have a full slate this week. We got a few news items, a set of articles to cover, and then a couple of discussion things that we're kind of squishing together, which I think will be fun to discuss in relation to what's happening in the world of Python. And then, of course, projects.
Who doesn't like squishy discussions?
Yeah, exactly. All right. So you ready to start it off with the news?
Sure. First bit is PyPy, that's PyPy, the alternate Python interpreter, has released version 7.3.16. This one includes Python compatibility for 2.7. Yes, they still do that. 3.9 and 3.10. So if you're into PyPy, go check that out. The next piece is PEP 745. This is an informational PEP announcing the schedule for Python 3.14. Yes, that's right. They're already thinking about 3.14.
Yeah.
I doubt I'll be the first to point this out, but that's 3.14. That's Pi, the number, which is just going to be so fun because we'll have PyPy or PyPI to get the Pi version of Python. So anyways, I might be the first to point out the obvious, but I'm pretty sure between now and Wednesday, October 1st, 2025, which is when it comes out, I won't be the last. And then finally, one little bit of not Python, but programming history news. The BASIC programming language just turned 60. BASIC was my first programming language. You're not going to catch me waxing nostalgic about a lack of functions, required line numbers, and a need for goto, because I started BASIC before subroutines. I'm happy to see that Python's a lot of people's first language now, not just because I like Python, but because it isn't a toy, and that's kind of what BASIC was considered way back in the day. How about you? Is that where you started as well?
Yeah, I'm one of those people that coded from the back of a magazine, a little text adventure into a friend had an Apple II, and then I eventually got my Atom computer, which was an Apple II. And so, I got to play inside BASIC quite a bit and did lots of go-to and loops and dancing around. Choose your own adventure style.
Yeah, I remember both Donkey on the PC Junior, which was hit the space bar and move the donkey from the left lane to the right lane so it doesn't get hit by a car. That code you could actually read and understand. And I remember magazine articles for the Commodore 64, which essentially was just sprite-based peek and poke, which is like settings and removing. And
Yeah.
it was just gibberish. Like you typed it in, but it was like, I don't know what it's supposed to do. Oh, is it doing the right thing? I have no idea. I learned no coding from peek and poke. But yeah, you could make pretty sounds and make pretty pictures. So
The most recent time I've heard about that was they were fixing Voyager, and they have a bad chip. I don't know if you heard about that whole story, but they were doing something similar, moving all the information over and literally peeking and poking to make it work across how many billion miles or whatever it is. Yeah, it's pretty crazy. What's your first topic this week?
I've got an article by Jason Brownlee, who writes for Superfast Python, which focuses on concurrent programming and optimization of your favorite language. That's Python, not BASIC. Just keep the thing going here. The article is called Async.io Handle Control-C. Now, you're probably familiar with the fact that hitting Control-C on your keyboard usually stops your program. What you might not know is that this is part of a family of signals in Unix. Windows kind of copies some of it. But when you hit Control-C in a terminal on Unix, the interrupt signal gets sent to your program. This signal is often shortened to the name SIGINT, not to be confused with signal intelligence for anybody who's a big Tom Clancy fan or has a military background. So your program is actually able to trap SIGINT. So the stopping of your program only happens if your program doesn't trap the signal. This is done on purpose so that you can gracefully shut your program down if you need to. Say you're got to write out a file or need to do a database commit, you can trap the signal and make sure that those things happen before your program actually exits. SIGINT isn't the only signal. On Unix, there's a signal for backgrounding a process and a kill signal that isn't trappable, so that if your signal for trapping signals goes awry, you can still kill the program. Anyway, so as you might intuit from the article's title, Async.io muddies the signal trapping waters. When you've got multiple threads or coroutines running, the main process is what gets the interrupt signal from the OS. If you do have concurrent things going on, that means you now have to decide how to handle the signal and what to do with all those concurrent activities. What the article does is walk you through step by step as to how to build a custom signal handler, where in your coroutines to trap it, and how to deal with such a graceful shutdown to make sure that all the coroutines finish doing what they're needed doing and receive what's called a cancel inside of Python to handle all of this. So if you're doing some async.io, this article is definitely worth the read so that you don't leave little orphaned processes happening and have weird stuff going on in your system just because you're doing concurrency.
Shut all those Pythons down.
Yes.
Well, my first one is about APIs, actually a very specific API for OpenStreetMaps. It's called Overpass API. And this is on the Pybites blog. That's Pybites. I was on their podcast recently, and so we've been following their blog, and they have a variety of people contributing. And this one is from Judith Valkenroth. And it's a kind of a tour of what this API can do. We talk a lot about tools that can create an API, Fast API, Django DRF, and Django Ninja, which we talk about a little bit more later. But often people are interested in consuming the data and pulling it out of an API, and maybe you're interested in exploring that or practicing that. And I think this is a really good overview, not only of how this particular API works, but generally how they might be organized, what sort of data structures they have and so forth. And this is a very rich one. There's a lot of data, the whole planet, if you will, of data. And one of the best ways to get familiar with it is to sort of just play around with going to the website, which is, I think it's just OpenStreetMap.org. As you bring up the map and you're looking around, you can right click on any particular element or node, and you can see the information about it. And she has some visuals there kind of indicating that stuff. So like she clicked on a particular bus stop, and there's a bunch of tags that are associated with that. So you can kind of see the structure there. Does it have a bench? Does it have a trash can? Is it lit? Does it have a shelter? Stuff like that. And then it says things like, oh, it's part of this way. And so this connection of nodes and how they're connected, the node, the way, and the relations, and all these sort of tags that are connected there. You also kind of get an insight of how all this information is sort of crowdsourced. You can actually see the people that contributed, which I think is really interesting. I brought up my own personal neighborhood, and there's a lot of bike paths / walking paths around, and somebody is really into doing that stuff, which I think is kind of cool. I guess they want that information for themselves. And so they've added all those around the particular area I live using, I guess, satellite imagery or other things like that to kind of get an idea of it. How do you get into consuming this? Well, you can play around with it directly in the URL. If you've ever done that before, you might have seen the question mark and build a query string out to kind of see the different elements that are in there. She describes that process, but also then describes using wget and the type of output that you would get in that particular case. And then it's an intriguing list of like how the tags kind of connect. And there's a lot of really deep information that I wasn't expecting, like tourisms, amenities, historic stuff. One of the fun things that she found is a public oven. I'm kind of intrigued by that idea. I'm actually a little more intrigued by the idea of listings for public bookcases, but this is probably Europe and not so much US kind of stuff. So the rest of the article digs into using this thing called Overpass, which is the API sort of connection to it, and then a Python wrapper for that. I think this is a really good resource. She talks about using that API, Overpass API, first with using requests and then using the Overpass API Python wrapper. And I found it a good resource. Like I said, if you're into consuming APIs, it's nice way of building from, okay, show you what it looks like as far as the web, URLs, then manually building on a query and then sort of graduating into using Python in a library. She shares another Python-based tutorial that is a Medium one that actually continues on this idea of using the Overpass API in Python. So if you want to continue on that, you can. And then we at Real Python have another, if you are looking for even more sort of general ideas on how to use APIs, this particular tutorial is called Python and APIs, the winning combo for reading public data, and has a variety of other types of things that you might explore, like GitHub. You can kind of practice using these public data resources. Something to check out. What's your next one?
I've got a new article from Stephen Gruppetta on Real Python called What's Lazy Evaluation in Python? And it starts out by telling you as programmers, you're all lazy and you don't work at, no, not at all. Lazy evaluation.
That's for later.
That's like, yeah, actually, we are going to come back to that later. Lazy evaluation is the idea of not generating a value until you actually need it. The most common example of that inside of Python is with generators. So if, like, say, you've got a process where you want a series of values, a list gives you all of those values all together, whereas a generator only creates those instances as you process them as you go along. And that's really where the article digs in. It starts out by sort of showing a small example of generating a bunch of random numbers and the difference between, say, creating a list of those versus getting each one of those numbers generated as you use them inside a for loop or somewhere else where you're using them. There are a lot of examples in this article. So he starts out talking about built-in data types and how they work, the built-in functions, zip and enumerate, and how they work. Enumerate's a great example. You typically use it around a list and you get back pairs, the pair being a counter of how far you are through the enumeration, and then a value from it. And it is lazy evaluation. It does not reprocess the list. And so as you go along, you get little pairs out. And if you just instantiate enumerate, what you'll get back is an enumeration object rather than the set. And so you then loop through that and use it as you go along. He starts there and then digs in a lot deeper. There's a lot of stuff. There's a library inside of Python in the standard library called itertools. It provides a whole bunch of functions that allow you to iterate through things. And this iteration process is typically done in a lazy fashion. So the first example he uses from itertools is chain, which allows you to treat two sets of sequences as if they were one sequence. And again, because it fits in the example with the article, you go through the first piece and then it go through the second piece, and it's not generating a new thing. It's lazily iterating through each of those together. So you don't have to think about them. You don't have to squish them together. And what generally the big advantage of this is that means you do not have to create a duplication.
Yeah.
So if you just added two lists together, now you've got to take up all the memory of both the first list, the second list, and this third combined list. With iteration and with lazy evaluation, you don't need to create that third list, which saves you a whole bunch of memory. For large lists, this can make a big difference. The article goes on to show you generator expressions and generator functions, which are things you can write yourself in order to build this kind of functionality, and then does deep dives into all sorts of tools that you can use to go along as you go there. And finally, the article finishes off showing you sort of the advantages versus the disadvantages of lazy evaluation. I already mentioned sort of the advantage there of saving you the memory. The disadvantages is you can't do things like slice into them because you can't go immediately to the 50th thing because that's not how it works. You kind of have to go through in sequence. So this, as with everything in programming, this is a trade-off, and you pick the trade-off that works for your situation the best. Stephen writes great stuff. He's got a very, very approachable article style, and this one is no different. It's an easy read. So if you're interested in this kind of stuff, it's a good place to start.
Yeah, just had him on the show. That was very fun to talk to him, and we talked about his book. I titled the episode about it being like friendly and approachable, and that's definitely his style. And then what's funny is that this, I feel, is very related to the article that just came out this week, just after the lazy evaluation one, which is about sequences, which kind of makes sense. And if you've dug at all into generators, I think this is a really good build on top of that, of like kind of what's happening and how they work with this lazy evaluation one. So more resources for you to dive in deeper here at Real Python. Fix application issues before they become downtime with Sentry error and performance monitoring for Python. One engineering leader that used Sentry said the time to resolve errors went from days to minutes. Whether you're taming Python's processing power or controlling JavaScript's flow through Node.js, backend infrastructures are as complex as they are valuable. With Sentry, you can trace issues from the front end to the back end, detecting slow and broken code to fix what's broken faster. Within minutes after installing Sentry, software teams are able to trace Python performance issues back to poor-performing API calls, as well as surface all related code errors to fix what's broken faster. Installing is just 5 lines of code, and Real Python listeners get 3 full months of the team plan free with the code REALPython on sign-up. That's RealPython with no space. Check it out at Sentry.io. All right, well, my next one is a data science topic. It is by Kevin Markham, and his site is dataschool.io. This is not something that I've personally run into, and I wonder how much controversy and potential teeth gnashing goes into this idea and this concept. But the article is titled How to Prevent Data Leakage in Pandas and Scikit-learn. There's a couple concepts being covered. He starts with this sort of premise that you can pretend you're working on a supervised machine learning problem. Your data is in a pandas data frame, and you discover, oh, we got some missing values here in a column. And you really think that column is important to what you're modeling, and so you want it to be a feature. Well, how should you do this? So there's this idea of imputing, or basically having a tool like pandas sort of guess values for you inside there, which I think is a really interesting idea. So in this process, option 1 he has is you just fill in the missing values in pandas, imputing the values, and then you kind of continue on. And then there's another way that his general leaning for this entire article is you should probably leave it to a tool that is designed for creating models and doing stuff like that, which is scikit-learn. Is you would pass that original data into scikit-learn and then perform all the data transformations, including the missing value imputation with scikit-learn. I hadn't heard this term data leakage. Again, I haven't been in a situation where I wanted to just say fill in some values because I truly wanted to use a column like this. But the concept is a little weird. And the leakage is not like data's disappearing. It's that it's crossing over into your other process of you start by training your information, but if that same imputed data is over when you're testing in that data also, then you got a problem because it's basically sort of verifying what you've created by this imputed data. And so I found a kind of another example that's a little better in the idea of it. This one's actually called group leakage, but it's a similar idea. there's this example on this, and I'll include the Wikipedia on it. By not having a grouping inside of a split column, this experiment that was looking at x-rays to try to determine if the patient had pneumonia, there were 100,000 x-rays of 30,000 patients, meaning that there were about 3 images per patient. By not having the grouping and by having this mix of patients' records being both in the training data and the testing data, what their model did was identify people. It did not do what it's supposed to do, which is predict what pneumonia is supposed to look like. So you should have kept, all those particular patients in one group or the other and not have it sort of randomly cut across the two. And so that made a little more sense to me in the idea, but I still kind of feel a little weird about this idea of like coming up with random data. So what scikit-learn will do is it will actually, in the process of creating the split of test train split, it will actually only create the values in the training data and then leave the testing part alone. He talks about a couple different tools for doing that inside scikit-learn. It's a pretty short article. I wonder how much this happens, and I wonder if this is a problem with reproducibility and replication of results by imputing values. And I would wonder why you wouldn't just maybe leave that value out.
Yeah, I think it comes down to like if you think that piece of data has strong correlation to the training, but then it's missing in 10% of the cases, you don't want to throw that value out as part of the training information, but now you've got to deal with those 10% where you don't have it for whatever.
Yeah.
Your choices are guess at it.
Which
is really what it is, like fancy guess, right? There's guessing, there's fancy guessing.
Oh, no, it's called imputation. Sorry.
Yes. And then there's dropping stuff.
Right.
And honestly, I think this might be a bit of an oversimplification, but it kind of reminds me of like deciding when to do rounding.
Yeah.
Right. So if you round too early or round too frequently, you can end up with a starkly different answer than if you round at the end, right? And I think really what my takeaway from this was, particularly when you're trying to do machine learning training, whether it's imputation or anything else, the order of these things can make a difference.
Yeah.
The machine learning industry is filled with examples of, we trained it to recognize there was a ruler in the picture rather than what was and what wasn't a tumor, right?
Yeah, exactly.
So it's definitely something that you've got to be careful with when you operate in this space.
Yeah. This is sort of a related thing. I'm going to be talking to Brett Kennedy about his book, Outlier Detection in Python. And I thought maybe he'd be interested in talking a little bit about this, at least add a little bit of light to it. He's kind of working on the opposite end of the spectrum, though. In looking for outliers, he's trying to find literally the anomalies, like financial fraud, bot activity, and malicious network attacks and stuff like that. But
it can also be used for cleanliness, though, because like statistics, it's a very common practice in statistics to drop like the top 10% and the bottom 10% so that you're dealing with the middle, right?
Sure.
That you don't swing your average in a certain direction or something. So again, identifying the outliers it's kind of the opposite of imputing. It's find the crap that's destroying our results rather than
it's pulling us way off course.
How do you, and then you decide to chop them or do whatever you want to do with them. Yeah.
Yeah. And I thought that too, but I think that he's actually focusing on actually truly like, I want to locate those anomalies because they're actually showing me problems, and things that we want to discover.
Yeah, it's I seem to remember there being an example in the book too where the outliers could cause like data grouping to create artificial groups.
Oh,
like it makes it look like there's two groups when there actually isn't, because the outliers are pulling your split line in the wrong direction, right? So it's a related kind of thing. It's the how do we make sure our data is helping us solve the actual problem rather than getting in our way. Real life is messy, right? Real life data is always messy is the problem.
Yeah, truly. Cool. Like that takes us right into our discussion. We've mentioned a couple times that we're going to cover a couple things here.
Yep.
First one is the Django developer survey results.
Yeah. So we've got two topics, and I tried to come up with some convoluted way of saying they're related and decided against it. But both
okay.
topics involve developers. I'm pretty sure I could say that about every discussion we've ever had. So, anyways, yes,
right. And they're both surveys of sorts.
Exactly, sir. Yes, you're right. So the first topic is the results for the 2023 Django Developer Survey have come out. We've discussed the Python Developer Survey before, and like that one, this one is sponsored by JetBrains. So thanks to those folks for doing this. There's some interesting data in here. There are a couple things that kind of stuck out for me personally. First off, there's almost a 70% adoption rate of the latest version, which at the time of the survey was 4.2.
Very impressive, actually.
Yeah. On one hand, was kind of surprised, and then I stopped and sort of thought about it. And honestly, the difference between 4.1 and 4.2 were minimal. So it was a relatively painless progression, and I think that makes it easier. For database adoption, the big winner was Postgres. 76% of respondents said they were using that, followed by 43% for SQLite. Do note this was multi-select, so the percentages don't add up to 100. If you're wondering why it can be 76 and 43, math doesn't quite work there.
Yeah.
I was a little disappointed to see that 21% of folks don't do automated testing. I'm hoping that's partially because of things like hobby sites. My cookbooks site, which is built on top of Django, there's no testing there. So
right.
The flip side of it is my consulting career has told me that that's probably overly generous. It's always depressed me how many times I've gone into a large institution like a bank or an insurance company to find out, oh, you're still doing manual QA. Isn't that great? And then the other one that was a bit of a pleasant surprise was the prevalence of Mac OS. So 36% of respondents said they'd use Linux. 32% said Mac OS, and that's almost 3 times the adoption rate of Macs in the general public. They're only about 10% generally.
Yeah.
And it's also 3 times the reported usage rate of Windows without the Linux subsystem. So pure Windows without it as a entry point to Linux. And I suspect that's for the same reason Linux is out there.
Yeah.
Where most people are doing web development, they're doing Unix on the back end. And Mac is a very pretty version of Unix is really what it comes down to. But I was just sort of surprised at the adoption rate there. And then the last one that was for me was there were 2 questions that sort of depressed me. First, my treasured Vim only has a 7% adoption rate. And second, I'm 2 sigmas to the right of the mean on the age graph. So from one old fogey to another, what stood out for you?
I like the term lovably vintage. So
lovely used, yes.
I'm younger than basic.
Yes.
All right. Yeah, the 2 things that are related to, you were talking about testing. They have one about continuous integration systems, which is probably a higher value. It's like only like a quarter of them say none. And then there's like configuration tools, which is actually pretty low, like having tools that kind of do that stuff for you automatically. So I thought those were kind of interesting. I thought the third-party framework stuff is interesting. Django REST framework has dropped a little bit, not a lot, but I would guess that maybe Django Ninja is creeping in there and taking away some of that.
I was surprised it didn't show.
Yeah. I think somebody mentioned it, and so it's growing. I had a question about models versus views. I know this is like really Django nerdery, but I don't know. Are you with the 69% that says models and the favorite core components, and maybe don't use the view based stuff as much?
I think I'm trying to remember what boxes I checked. I suspect it was probably the admin.
Yeah.
Would be my guess.
Which is very handy.
Probably authentication. I can't remember. Core components are core components. I use almost all those things all the time.
Yeah.
So I don't know, what difference it makes. The models for non-Django folks, the model is what sits in front of the database. So if you're not using the database, you're probably more likely to use something like Fast API. So the fact that you're using Django kind of tells you that you're there anyways. So it's not surprising. And that's part of, why I checked the box for admin. It's the same thing. It's a built-in tool that allows you to muck with the models, and it means you don't have to do very much coding to get a GUI to interface with the database. Yeah, I found it almost an odd question.
Yeah, sure.
But
yeah, the other one that I thought was interesting is sort of the growth of HTMX as a quote unquote Java framework. How a lot of these other ones are kind of dipping a little bit, React and Vue and so forth, and whatever the flavor du jour. I think people are not as interested in dealing with the overhead of having to have all that JavaScript in your head to work with it.
Yeah, before I discovered HTMX myself, I was using Vue.js a lot. And it wasn't because I really wanted to. It was because sometimes your pages need some dynamic stuff.
Right.
And what I really like about Vue is the fact that it allows you can adopt varying degrees of it. So if you just need a tiny little bit of dynamicism on a page, you don't have to all or nothing. Whereas, the React and Angular of the worlds tend to be rather opinionated, and your entire site has to thou shalt TypeScript rather than. But all I needed was an auto select here, so I tended to use Vue because of that. And HTMX just makes that so much easier. There's just so much less code. And because of the way HTMX works with partial pages, it integrates very nicely with Django, because Django can feed out partial pages to your heart content, right? So you're basically taking advantage of the templating system, and it's very 1.0 style coding with very 2.0 style interfaces. So yeah, it doesn't surprise me that it's taking off.
That's nice. I thought it was interesting. I looked at the CSS frameworks. I thought that was interesting too, that Bootstrap is kind of dropping off after a long time at the top. I would argue it's still at the top, but there's something called Tailwind.
Yeah.
That's growing. And then there's a few others that I've seen inside there. But yeah, Bootstrap's been around for a long time. I would say that you can definitely tell the age of a site that's using it now.
Yes.
So yeah, cool. It's good to see that. I was mentioning to you before we started that, I've 7 or 8 years have been kind of paying attention on the side of watching Django and having done a little project myself and tried to set up some stuff at work and just paying some attention to it. And it just looks so healthy and growing. Yeah. And, the Django knots thing that we mentioned earlier for onboarding contributors, and it just looks good. I like the batteries included of it in a lot of ways. So,
of course, we're not going to get through this topic without, the old joke about marathoners. It's how do you know somebody ran a marathon? They'll F and tell you.
Or went to Harvard.
Yeah. Well, so it goes the same for authors. So we can't get to the bottom of this without me shilling a little bit. But I was pleased to have Michael Kennedy of Talk Python acquiesce to writing my foreword for the book.
Oh, nice.
One of the things he mentions in it is just how deep the Django community is, right? Like outside of most of the time you see language conferences, you very, very seldom see library conferences.
Yeah, frameworks, yeah.
Or if they are, they're libraries, like they're a track inside of a conference. Whereas, DjangoCon is huge, right?
Yeah. There's European versions and so forth. Yeah.
There's a North American one, European one, and an African one now.
Oh, wow.
And so the community's very, very vibrant, and there's a lot of sort of support there. And one of the things he kind of said in the foreword is sort of, welcome to this world. Like it really is a very vibrant thing. And people they're actively trying to figure out how to get more contributors, which you see in very, very few places in the open source world. Often it's go away, little boy, you're bothering me. Whereas here it does seem to be very an accepting sort of community. So I think that's definitely part of it.
Yeah, cool. This week, I want to shine a spotlight on another Real Python video course. It's connected to one of our discussions this week. When you start building any new Django web application, there's the fundamental step you need to tackle first. The course is titled How to Set Up a Django Project, and it's based on an article by former guest and Real Python team member Martin Broyce. In the video course, Martin takes you through setting up a virtual environment, installing Django, pinning your project dependencies, setting up that Django project, and starting your first Django app. It also covers techniques to manage a slimmer structure for your Django project. I think it's a worthwhile investment of your time to learn the fundamental steps to properly set up a Django project and to get a solid understanding of the structure of a Django application. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and all Real Python courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com.
So, shall we move on to topic 2?
Yeah, let's go ahead.
All right, so...
Another survey. of sorts.
Sort of, yeah. Our next source of discussion is an article by Dakesh Gupta, and it's titled, I asked 100 devs why they aren't shipping faster. Dakesh is the founder of Greptile, which is an AI coding tool. So I suspect he talks to devs all the time as part of that whole sales process. The article name checks a couple dozen companies, almost all of which are household names or would be household names for houses containing programmers. The article goes into detail about these kinds of conversations he's had, but I'll start out with the two things that surprised him. First, nobody had to pause for an answer. You asked them, why aren't you shipping faster? And everybody immediately went, oh yeah, off the top of my head, here are our reasons.
Yeah.
The reason this is a bit of a surprise to him was that there's sort of this aspect of, well, if you know that, why wouldn't you be fixing it? Well, and as we'll get into in a minute, sometimes it's out of our control to fix.
Yeah.
And then the second surprise he had was how many of the answers were actually, tool chain answers. So, slow to build, slow to compile, slow deploy times. I find it interesting because the rest of the article spends very little time there, but it's definitely one of the topics that comes up. And I think it comes up because it's sort of the immediate thing that annoys us code junkies.
Right.
So what stood out for you here?
Oh, it started with some of the stuff that's really hard to solve, in my opinion, like dependency bugs, like, hitting random mysterious bugs with libraries and reading into Stack Overflow to try to find out what's happening or GitHub issues and so forth. And that rolls into this next one of a complicated code base, where they're not updating their documentation and it becomes like a vicious cycle of like shipping features versus like keeping the docs up to date and so forth. I wonder about that, like this idea of cross languages. We just mentioned, that idea of using JavaScript with Django and so forth, and how that isn't like doubling the complexity. It's sometimes like multiplying it in a much larger fashion. So, but the really interesting stuff is like, as you get further and further into it, it becomes more about the people and less about the technology.
Yeah.
And so, stuff like the QA loops, meetings, reviews, weird stuff like developers having too much free time and personal vendettas and prejudice. And it's just like, I have only been in corporate America for a short period of time here and there. And so I kept saying this to people at different jobs I had that were inside large buildings that had lots of offices, where I would say, is this normal? And I guess I don't know, what is the saying? Every family is, broken in its own way or whatever.
Yes.
I don't know the quite as well as I wanted to, but and I think that's it. Like, every unhappy family is unhappy in its own way. And so it just makes me like, kind of like, I don't have a lot of ideas of like how you would solve these things. Mostly I think about like, man, I would not be interested in them. I thought of some things that I've talked to people in the industry about, at least increasing communication and sort of making sure the engineering teams can potentially work together. And that was like the conversations that I had with Pablo about Bloomberg. We talked about guilds and this idea that they have internal guilds. This is where a bunch of people that are interested in Python can go and learn more about that and so forth. And so people came from other teams, and then that's kind of spawned conversations across different silos, if you will. And I thought that was interesting. And I don't know if it solves that.
Well, so guilds can be one of the reasons guilds have become more popular in the last sort of decade or so was the old waterfall way of doing things was you had the development department and they were on a different floor than the QA department, who were on a different floor from the BA department, and
its own form of waterfall.
and the agile space very much tries to have research team driven pieces. So you get a group of people together who are solving the same problem, which means inevitably you have some developers, some QA, some BA folks working together.
Yeah.
We can debate for hours as to, what works, what doesn't work, but that at least then you've got a team who are concentrating on that problem and solving the problem. The downside of that is it becomes a lot harder to cross-pollinate ideas because now all the developers aren't on the same floor. So the guild concept kind of came out of that, where you end up sort of, lunch and learns or whatever, where the developer folks can all leave their feature-focused teams and go to a process-focused area. Some organizations will try to put, I don't want to call them management, and they're not really leaders, but sort of architect-type people who are watching what's happening on the different teams and are in charge of trying to make sure the best practices are being handled, right? So that you can get growth across the teams.
Yeah.
And it's a hard problem, right? So some of the things that you have by having those development silos, these one set of problems doesn't show up, but you get a different set of problems. And then you get rid of those silos and make them feature focused, and that solves one set of problems and creates a different one, right? So it's always, these things are always a trade-off, right? Take the next thing I'm about to say with a grain of salt, because of course this is how I make my money. I have found that consulting can help in this. And the reason for that is kind of counterintuitive. Oftentimes what consultants are doing is they're being paid an awful lot of money, and because of that, they're listened to. So I can't tell you how...
I could tell you that how often they listen to them and not the people that are there.
Yeah, so I can't tell you how often my job has been go in, talk to everybody, write down what they say the problems are, and then report those problems to management. And it's stupid, right? Because if I wasn't there, if I wasn't there, they definitely could have still solved the problem,
right?
Just by listening to their own people. But coming in as an outsider and providing a little bit of guidance and massaging a little bit of data together, magically all of a sudden management listens, and so they can actually make a bit of a difference. I would almost like it if the world didn't work that way, but it's something you can almost take advantage of. So
sure. I mentioned some other things to you kind of before we started to that I was thinking about, because we were going to discuss this, and I feel like maybe we're in a cycle as far as technology, the world that we're in. I mean, there's definitely this whole AI hype thing, which is kind of becoming a little bit much. There's a lot of these things that are coming out where they sure did ship it, but it didn't have the software and it wasn't working and all this other sort of stuff. And so who is pushing so hard to ship that stuff that isn't done? And I feel like, they're answering to a whole different set of people, and it's not necessarily like an overall company goal. It's like the salespeople, the advertising people, the marketers, and just saying, oh, well, we'll just fix it later. I mean, we see it in so many industries. The video game industry, that's, we're beta testing games now, through the pre-release cycle and so forth. And sometimes that's okay, which is interesting to see things get developed later. But in other times when it's like a physical product and you're paying potentially a monthly fee for something that doesn't really work is kind of nuts,
The balancing act is really, really difficult. If your technical people are too much in charge, nothing will ever go out the door because they want it perfect.
Right.
And if your marketing people are too much in charge, then the deadline becomes about everything. And,
right. We bought the ads already.
There's definitely an assumption that first mover gets an advantage.
Mm-hmm.
I'd love somebody to actually do a study on that, because
there
are some of the key, several of the letters in FANG, most of them weren't first movers. Facebook was not, Google was not, and yet they're dominant, right? I don't know, that's anecdotal, right? So I don't know how often first mover actually makes a difference, but business-wise, that often tends to be the answer. We have to be first mover. And so then you get half-baked going out the door. The other part of it too is, and this comes from sort of the organic processes that happen in the different departments that happen inside of an organization. You always hear developers swearing about sales because they've promised something in order to, oh yeah, of course it does that, and then it doesn't, and then development are the ones who have to clean it up. Well, sales wants to make sales, and if sales should want happy customers, because that allows them to make more sales. If your management is properly thinking about how that happens and making sure that the salespeople are, one of the things that I've worked with organizations where the commission doesn't happen unless the cust-sat numbers of a certain size, right? And so like you get half your commission when you make the sale, and you get the other half of the commission once it's actually been implemented and your cust-sat score is above, 8 or whatever the number is. And it's a completely different dynamic because the salespeople are they want to work with the engineers because they're not going to get their money unless, right?
Right.
And so there are things management can do to try and help this kind of stuff. But, we have a long history of not doing it. And unfortunately, the vast majority of C-suite are not engineers. And so
Yeah,
the MBAs rule the world.
Definitely what seems to be happening in a lot of Silicon Valley, and then just the idea of let's make sure that we just pay attention to, the stock and so forth. And I feel like there was a little bit more of a wall, but it's just gone now. It's like, seems like it's completely fallen apart.
Well, speaking of falling apart, like Boeing's a case study in this, right?
Oh God. Yeah.
Right.
Yeah.
So they were an engineering driven company, and then the merger happened and the MBAs took over, and it's been downhill since then. So
yeah. I heard about the slide just this morning. I don't know if you heard that one.
No, I missed this.
There's an emergency exit slide that got detached in flight or whatever.
Oh,
and
fun.
Another Boeing. And then they couldn't find it. And then they found it at the one of the lawyers who's suing Boeing's house. At least that's what I understand. So yeah, it's pretty bananas.
That's fantastic.
Hey, you guys lost this? Anyway, I guess it's sort of sobering in a way. I wish there was more like solutions or ideas in there for, it's, first step, spot the problem, sure. But from there, like, what can you do to kind of get beyond it? And I don't know if things are so endemic, inside of a company that you can't quite get past it. I don't know. I just feel like we are definitely in a cycle right now where a lot of this is happening, and the push to ship things is like so strong. And then the push to cut the bottom line is there. And like, okay, it's just not really sustainable.
Well, one of the things I've tried to coach inside organizations is make sure that the tech side understands that without the sales side, they don't get paid.
Right.
And make sure that the sales side understands that without the tech side, you don't have a product to sell. So let's start talking about this as a problem we're solving together rather than, creating these fiefdoms, right?
Yeah. Anyway,
shall we move on to projects?
Yeah, I think digging into projects is probably a good idea.
We're not going to solve this. So
yeah. So mine, it uses two things that we talk about a lot. One is pipx, which you've mentioned maybe even last week, I think. And the other is UV, which you've mentioned a few times, which is a tool that in some ways can be for packaging, but also can in some ways replace what pip does. So this is a project called pipxu, and it's installing and running Python applications in isolated environments using UV. The project's by Mark Blakendy, and he goes by Bullet Mark. And then the other person that is on the project is Patrick Zadja. Each package and its dependencies are insulated from other applications and from the system Python. That's kind of a hallmark of pipx, which is really kind of nice. It's a good way to install tools that you use across a system and that you want to have access, but it won't be embedded in other particular projects you have. So again, if you're familiar with using pipxu is just kind of a thing that provides a speed improvement in a lot of ways. It also is lighter weight in the sense that pip is one of these dependencies that does take up some space, and it also is updating itself pretty often. And so this is something that on the UV side is going to be a little quicker. I installed it, played around with it. I played around with a couple different tools that I like to use. And yeah, it just worked really, really simply. In some ways, it was a little more verbose in its installation, which was kind of nice, kind of showing me things that were in there. And I don't use pipx all the time. So maybe I would, could turn on a different flag or two and I would have seen similar sort of stuff. But I like the defaults that it provided. So yeah, if you're interested in pipx and you're interested in maybe speeding it up a little bit, this is taking advantage of the enhancements of UV. What's your project?
I've got two, which are related to each other.
Okay.
The first one's called Tenacity, and it's by Julian Danju. This library is for doing retries in your code. So it started out as a fork of a library actually called Retrying, which is no longer maintained. So let's say you've got a flaky network connection and you want to try sending something a few times before giving up. Tenacity ships with decorators that you can apply to a function that give you this functionality. For example, the decorator can catch exceptions and then retry the function again. And if the function passes, then Tenacity does nothing and you can go along your merry way. You can control how many times to retry. You can control how long to wait between retries, conditional retries based on specific exceptions, or you can call a truthy function that decides whether or not to retry it. And in fact, it also has tools to hook in with managing logs and monitors in case you want to, give information about the retrying. So neat little library. And then the second project is a wrapper to Tenacity, and it's called Stamina. It's by Heineck Schlawak. We've mentioned him on the show before. Back in episode 145, we featured his article on the Knox testing tool. The easiest way to explain Stamina is to quote the README. Stamina is an opinionated wrapper around the great but unopinionated Tenacity package. So essentially, it tries its best to pick reasonable defaults for things and to provide some helpers. So for example, out of the box, Stamina, rather than retrying on all exceptions, it only retries on certain exceptions. So, that network example I was giving, IO error is probably a common one to do, but if it throws up a key error, then you wouldn't. Likewise, it uses exponential backoff to wait between retries, which is a good philosophy, and limits the number of retries and the total time taken. So it's essentially taken good ideas about how to do a retry and implemented it using Tenacity. The one feature I really like is it also has a helper method that allows you to globally disable the retry mechanism, which can be really, really handy when you're testing. And the documentation shows you how to do this with a PyTest fixture. So if you need retry stuff, these libraries are great. If you're already a Tenacity person, I definitely recommend taking a look at Stamina because it might actually save you some coding.
You mean tenacious person, right? I like the attempts and so forth. You can kind of like put values in for that. And I guess you would, in the testing runs of these things, you would just maybe lower it to 1 or something like that, just to make it go through.
It has a global setter-getter kind of function in the library, and you essentially just say, turn it on, turn it off, and it's as if the decorator's not there.
Okay, awesome. Well, thanks for bringing all these PyCoders weekly articles and projects this week and discussion topics. Thanks, Christopher.
It's great. I'll see you in a couple of weeks.
Okay. And don't forget, installing Sentry is just 5 lines of code, and Real Python listeners get 3 full months of the team plan for free with the code RealPython on sign up. Check it out at sentry.io. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.